This is Dr. Holt. In this video I want to talk about how to calculate the moment inertia of a rod about one end and about the center of mass. So first thing I've done is define what the moment inertia is. It's going to be the integral of r squared dm. dm is going to be the little mass of this segment right here. Now I have a rod, and we'll call the total mass of this entire rod of mass m. If I take mass m, I divide it by the length, the entire length, then I get like how many kilograms per unit length this object's going to have. If I multiply it by dx, then what I would get would be the actual mass of the little segment dm. So this little segment would have a mass equal to m over l dx. I'm going to take this part out of the integral. I'm going to replace it with what I've defined here. Okay, so far so good. Now, my r value here is going to be the distance from one end to the middle of that segment. So here I defined this as x. So I will take x out right here and take r out right there and replace it with my x value. Alright, now I'm going to set it off, the integral up from I. I'm going to pull out my constants. My constant is going to be the m over l. And then my integrate of x squared dx. But then what are the parameters? I'm going to be going from this end, which is going to be 0, to this end, which is L. Alright, so at this point we're ready to go ahead and do the integration. And when I do that, I will get I is equal to m over L, from L to 0, of x squared, x cubed. Do it again, I'll just erase it. Of x cubed over 3. I go ahead and pull my constant out, then I is going to equal m over L, 3L, from L to 0 of x cubed. When I do that, I will get m over 3L times L cubed minus 0 cubed. And what that will leave me will be I is equal to m over 3L, I'll go ahead and simplify here in just a second, of L cubed. I can simplify that. L cancels out here. This becomes a 2. And the answer will be 1/3 the mass times the length squared. And that's the definition of the moment inertia of a solid rod about one end. Now let's come down here. I've drawn another picture down here. And now we're going to work about solving what this from the center mass. I'll put a dot right here. We're going to find out what would be the moment inertia around this point right here. It's going to work basically very similar to what I did above. First thing I'm going to define is let this be mass. Then this little segment would have the same type of dm. The mass of that little segment would be m divided by, now let this be negative L over 2 and L. That would still have a length of L, times dx, where dx is the thickness of this little, my little piece right here. I should have moved this over. Let me just slide this over here real quick too. Moved it over from the above picture. That being my dx. Okay. So now we're going to do everything almost identical. We put I is equal to the integral, and we'll make this negative L over 2, and we'll make this L over 2. We'll go ahead and put in, let's slide this over 2. We'll take our variables and put them on the outside, or constants, put those on the outside. I'll just erase this. Okay, I put my constants on the outside. That leaves me dx in the inside. And again, the r squared value here is going to be how far am I coming back to this. That value is we're going to let that be x. So it would be x squared here. When I integrate that, I will get, again, m over L times x cubed over 3, with the limits being the negative L over 2 to L over 2. Alright, I'm going to go ahead and pull out all the constants. It's going to be m over 3L from L over 2 to negative L over 2 of x cubed. Okay, when I put that in, I will get m over 3L is not equal to times. I'm going to bring in the L squared first. So bring this in, L over 2 into this. That's going to give me L cubed over 8 here. Now we immediately go to this, we subtract, and now I bring this in, which is also going to give me minus L cubed over 8. We simplify, then I is going to equal to m over 3L of, here a big plus, so that's going to give me 2L cubed over 8, which will give me m, and we'll bring the 3 back in, that's 2 over 24, so that's m over 12. I'll have an L here, L cubed here. This L will cancel out, this becomes 2, and the answer will be the moment inertia about a solid rod, about its center, will be mL squared over 12. And that's where that value would come from, and you see this often in textbooks. So that's the integration, relatively pretty simple. That's the integration of solving the moment inertia about the center mass of a rod and about one end. And that helps you generate the equations just through integration. I hope that helped you. Best of luck on future problems.